In this lesson, may I present to you the fundamental theorem of calculus. So, every type of math has its own fundamental theorem, and calculus is no different. What that fundamental theorem does is it underlies everything that we need to know about that topic. So, here's the thing. Fundamental theorem of calculus has two parts. Now, they both basically say the same thing. So let's start off with the first one. The first one says that we have a function little f that's continuous on the closed interval a to b. Now, big F of x is equal to the definite integral from a to x. Now notice a could be any number. Now, so we're doing the definite integral from a to x of little f of t dt. Now, what you need to know is f is differentiable on open interval a to b, and the derivative of big F is little f. So that means that if you were to take the derivative of this integral, you would get out essentially that same thing. But notice, it doesn't matter what a is, but the top part has to be x. So here's the thing. In order to get f of x out, again, bottom part doesn't matter. It has to be a number. Top part has to be x. Okay? Now, I'm going to switch over and look at the second part. The second part basically says the same thing. Little f is continuous on the closed interval a to b, and in this case, we're just defining the notation. If I have the definite integral from a to b of little f of x dx, then it's going to be defined as capital F of x, big F of x, evaluated from a to b. Now notice, all we're going to do is plug in b first, plug in a second, and subtract. Okay? That's how we evaluate. But here's the thing. F is any antiderivative. Now that's a funny word. Antiderivative. Antiderivative of f. All that means is that the derivative of big F is little f. So, again, antiderivative, kind of a funny word. It means that they're opposites. One is derivative of the other. So, that's the key there. Now, I will make sure I mention to you before I get too far ahead of myself, the antiderivative could be lots of different functions. The antiderivative is essentially, I'm going to use the word a family of functions. There are lots of things that are antiderivatives of something. And it comes down to the fact that when we take a derivative, the constant term disappears. So as long as you just change that constant term, you've got another term that's in the antiderivative family. Okay? So again, fundamental theorem of calculus, big part here though, this is the great part, is in order to know that something is integrable, that we can actually calculate an integral of it, it relies on one thing, and it's in both definitions. F has to be continuous. Let me repeat that again. If you want to take an integral of something, that function better be continuous.